Hello everyone. In this video, we will explore the biography of Pieter Zeeman, a Dutch physicist who was awarded the Nobel Prize in Physics in 1902 for his discovery of the Zeeman effect. Today we are focusing on Pieter Zeeman, a Dutch physicist born in 1865 and who passed away in 1943. Zeeman is an important figure in the history of modern physics. He shared the 1902 Nobel Prize with Hendrik Lorentz for the discovery and explanation of what is known as the Zeeman effect, which demonstrates how magnetic fields influence the light emitted by atoms. This work helped link magnetism, radiation, and the internal structure of matter, and it contributed directly to the development of quantum theory and atomic physics in the early 20th century. Zeeman was born in the small village of Zoetermeer in the southwest of the Netherlands. His father was a minister in the Dutch Reformed Church, and his household placed a strong emphasis on intellectual curiosity, reading, and education. Although the family was not wealthy, they supported Pieter's interest in science. The Dutch countryside of the time did not offer obvious scientific opportunities, but Zeeman's curiosity pushed him toward careful observation of natural phenomena. Zeeman's interest in physics appeared early. In 1883, when he was still in secondary school, the aurora borealis became visible over the Netherlands. This was a very rare event at that latitude. Zeeman meticulously sketched the sight and wrote a detailed description of the colors and movements he observed. He then submitted this account to the scientific journal Nature. To his surprise and delight, the journal published it and even praised the precision of his observations. This publication marks Zeeman's first scientific contribution, and it showed that he already possessed the qualities required of a physicist: patience, accuracy, and a methodical spirit. Please subscribe to the Physical Chemistry DZ channel and click the bell icon to receive notifications and watch more interesting and educational videos. After finishing high school, Zeeman needed to study classical languages such as Latin and Greek because knowledge of these subjects was still required to enter a Dutch university. He studied in Delft, where he lived in the home of Dr. J. W. Lely, whose brother was responsible for major Dutch engineering projects such as the Zuiderzee works. During this period, Zeeman met the physicist Heike Kamerlingh-Onnes, who later won the Nobel Prize for his work on low temperatures. In 1885, Zeeman entered Leiden University, one of the major research centers in the Netherlands. There he studied under Onnes and Hendrik Lorentz, both of whom were at the cutting edge of theoretical and experimental physics. Zeeman eventually became Lorentz's assistant, contributing to research on magneto-optical effects. In 1893, he defended his doctoral thesis on the Kerr effect, concerning how polarized light reflects off a magnetized surface. After receiving his doctorate, Zeeman spent several months working at the University of Strasbourg before returning to Leiden as a Privatdozent, which allowed him to lecture and conduct research independently. Zeeman's major breakthrough occurred in 1896, shortly before he moved from Leiden to Amsterdam. While studying the effect of magnetic fields on light emitted by heated sodium vapor, he discovered that the characteristic spectral lines of sodium divided into multiple components when placed in a strong magnetic field. This was a remarkable observation because it revealed that magnetism could alter the radiation emitted by matter at the atomic scale. The phenomenon was quickly named the Zeeman effect. Hendrik Lorentz was informed of the discovery within days, and he immediately recognized its theoretical significance for electromagnetic theory. Lorentz soon showed that Zeeman's observations supported the idea that light was emitted by oscillating charged particles. The splitting of the spectral lines implied that these particles carried electric charge and responded to magnetic forces. From the magnitude of the effect, it was deduced that the particles involved were much lighter than hydrogen atoms and carried negative charge. This conclusion was reached before J. Thomson experimentally identified the electron, making Zeeman's work one of the earliest indications of subatomic charged particles. The Zeeman effect therefore confirmed Lorentz's electromagnetic theory and provided a powerful new tool for the study of atomic structure, long before quantum mechanics was formally developed. In 1902, Zeeman and Lorentz received the Nobel Prize in Physics for their combined experimental and theoretical contributions. The award recognized that the Zeeman effect had opened an entirely new field of inquiry: magneto-optics and the spectroscopy of atoms. The work had major consequences for both physics and astronomy. In astrophysics, for example, scientists could now use the Zeeman effect to measure magnetic fields in distant stars by analyzing the splitting of their spectral lines. For atomic physics and the emerging quantum theory, the effect revealed internal structures and provided evidence that atoms were not indivisible, but contained smaller charged constituents. Following his discovery, Zeeman accepted a position as lecturer at the University of Amsterdam in the autumn of 1896. He became full professor in 1900, and in 1908 he succeeded Johannes van der Waals as director of the Physics Institute. Under his direction, the institute grew into an important center for research in optics and magnetism. In 1923, a new laboratory was built specifically to support this research and was later renamed the Zeeman Laboratory in 1940. Zeeman taught and conducted research until his retirement in 1935, shaping generations of Dutch physicists. In his personal life, Zeeman married Johanna Elisabeth Lebret in 1895. The couple had 3 daughters and 1 son. Zeeman died in Amsterdam in 1943 at the age of 78 and was buried in Haarlem. During his lifetime, he was honored by numerous scientific institutions. He became a member of the Royal Netherlands Academy of Arts and Sciences, a foreign member of the Royal Society in London, and an academician of the Pontifical Academy of Sciences. He received prestigious international awards such as the Matteucci Medal, the Henry Draper Medal, the Rumford Medal, and the Franklin Medal. Today, Zeeman is remembered as a pioneer whose work helped reveal the atomic and electronic nature of matter, and whose discoveries continue to be fundamental in spectroscopy, astrophysics, and quantum science.